Welcome to section 1.5, Finding Linear Equations. So we're going to be looking at a few different cases. We want to find the equation of a linear function, and we're going to be given various information, but it turns out if we're given a point and a slope, that's a unique line. And let's just explore this idea. Let's say we had a unique point, right? We had a unique point, but we don't talk about the slope, so it could be any slope. And it turns out there's actually infinitely many lines that go through a single point. Whoops, I missed the point. But a unique point does not determine a unique line. There's actually infinitely many lines that go through a single point. And on that same note, if we are just given the slope, if we're just given the steepness of a line, but we're not given a point it's going through, again, there's actually infinitely many lines, because we can choose one of the infinitely many points and construct a line that goes through that point with that particular slope. All right, so to get a unique line, we actually need both. We need a unique point and we need a particular slope. And that's what determines a unique line. Okay, so we need a point and a slope. There's three different strategies depending on what information we're given. The first case is the most straightforward case when we have a slope and a y-intercept. If that's the case, we use slope-intercept form, named because it tells us the slope and the intercept, so y equals mx plus b. So remember the y-intercept, a y-intercept always has an x value of 0. So if we have a point like that, we can just plug in that b directly into the equation. So this first example, find the equation of the line with slope -7/2 through the point 0, 11/5. Well, we're given the slope, -7/2 x, and this point is special because the x value is 0. So that means this 11/5 is the b. So we can just write plus 11/5. All right, so there you go. So that's the most straightforward case. The next level of difficulty is when we're given a point and any slope. And if that's the case, we use something called point-slope form. And it's when we have a point, we'll just call it x1, y1, and slope m. That format looks like this. So again, it's in terms of y and x, but it's going to be y minus the y value is equal to the slope, parentheses, x minus the x value. All right, and this looks a little confusing. Just remember that the variable is x and y. So if it's not red, a number goes there. And where this format comes from, it comes from our slope formula. So we have that m, our slope, is equal to the difference of y's over the difference of x's. Okay, so we have our point, x1, y1, we have our slope m, and now xy is just any point of this line. And then notice if we cross multiply, let's get parentheses around x minus x1, and we multiply both sides by that denominator, or cross multiply, however you like to look at it, we get m times the denominator is equal to the top, y minus y1. And then if we just flip sides, right, if we just flip those equal sides, we get back to our equation, our point-slope form. All right. we're getting it. Let's see what this looks like in action. Now we're going to find the equation of us with slope -2 through the point 3, -9. Notice that this is not a y-intercept. So we can't use y equals mx plus b and say it's this. So this is incorrect. Because that point 3, -9 is not a y-intercept. So we're not allowed to use this. It's just a normal point. So we're going to use y minus y1 is equal to m times x minus x1. So it's a strategy. Slope in any point, not a special point, we use this form. Okay, so y1, x1, 3, -9. All right, so your x value is 3, and your y value is -9. All right, and then we have our slope as -2. All right, and then watch what happens. Remember, it has to be y minus the y value. Well, the y value is -9. So it has to be y minus -9. Likewise, over here, it has to be x minus 3. So we're actually looking at y plus 9. So when we plug it into point slope form, it's actually the opposite of what we see. So 3, -9. Notice we see -3 and +9. It's kind of flipped. Okay, so now that we have this, we're going to clean this up. We're going to solve for y. Our first step to solve is we're going to distribute that -2. So -2x, -2 times -3 is +6. I'll start up here. So distribute that -2. And -2 times -3 is +6. And then solve for that y. So subtract 9. And then we get our solution. Y equals -2x. 6 minus 9 is -3. All right, and there you go. There's our line. And we would check our work. We can always take that point, 3, -9, and plug it in for the x and y. To check our work. We're going to look at an alternative method. You guys can use either one, whatever you're comfortable with. I recommend just choosing one and using that all the time. That's the best way to avoid mistakes. But the alternative method for case 2, when we're given any point and a slope, is to actually use y equals mx plus b. But this is how we use it. So we know, let's scroll up a little bit, that our m is -2. So let's plug in all of our information. So m is -2. I'll even use the same colors. And 3, -9. So y was -9. And x was 3. Remember, mx means m times x, so -2 times 3. All right, so I just substituted in our point, xy, and our slope. And now we can actually solve for b. B is the unknown. Okay, so let's simplify multiplication first. Solving for b, so we're going to add 6 to both sides. And then we get that b is equal to -3. And that's not the answer. We're going to take this and we're going to put it into this y equals mx plus b form. So final answer, y equals, we know m was given as -2. And then we just figured out our b. Our b is -3. All right, so again, we substitute everything in for mx plus b. We had to figure out what b was. And notice it's the same answer as before. All right, so there you go. And again, we have a little bit more room here. If you wanted to check, always a great idea on an exam, you would plug in your point, -9,3, to make sure that there's a true statement. All right, so when we simplify everything out, we get -9 equals -9, which is true. So that means we did this correctly. If we ended up right here like -9 equals like -6, well, that's not true. it means we made a mistake. And we got to go back and we got to check our work and figure out where that mistake is. Okay. Let's do a quick example on our own. So I'm going to invite you guys to push pause. And you guys are going to find the line with the slope of m equals 3/5 through the point 20, 7. All right, so this is our solution. I used point slope form. So I plugged in your slope of 3/5 through the point 27. I distributed the 3/5. Don't be too intimidated by fractions because it does cancel nicely, right? 20 you can think of as 20 over 1, and we have a common factor of 5. So this is going to simplify to negative 12. All right, and then we add 7 to get our final answer. Now if you used y equals mx plus b and plugged in the slope and the point and solved for b, you're going to get the same answer. All right, final case is when we have any 2 points. And if we remember from geometry, 2 points make a unique line. So we're good on that. We know we're going to get a unique line. Our strategy is to find the slope first. Between the 2 points, which we can do. We did that earlier in the chapter. So find the slope and then choose one of the points. And proceed as before. And in particular, well, if it was an intercept, you would go to case 1. If it was not an intercept, you go to case 2. So let's say this in action. We're going to find the equation of the line that goes through the points negative 2, 6, and 3, negative 4. Our first step, it looks like, is to find the slope. So let's do that. And again, it doesn't matter if we start with negative 2, 6 first or 3, negative 4 first. It just matters that it's consistent. So I will start with 3, negative 4 first. So we're going to subtract our y's. Minus 4 minus 6 over the difference of the x values. 3 minus negative 2. Parentheses are important, especially when working with negative numbers. So we get negative 10 on top. 3 minus minus becomes plus. So 3 plus 2. And our slope is negative 2. All right, so we kind of have a choose your own adventure. We can finish the problem by using 1 point, let's say negative 2, 6. Or our other option is to use that slope we just found and use the other pair, ordered pair 3, negative 4. It doesn't matter. So let's do a couple different ways. Let's do the negative 2, 6. We'll use point slope form, so subtract the y. X minus a negative 2 becomes x plus 2. And we solve for y. So distribute that negative 2. Multiplying by negative number flips all the signs. And then you add your 6. So negative 6, or excuse me, plus 6 on both sides. So we get a negative 2x plus 2. And that would be your solution. And to check, if we wanted to check, I always like to check with the other point. So we could check with the other point 3, negative 4. So does negative 4 equal negative 2 times 3 plus 2? And it does, right? Because negative 6 plus 2 is negative 4. So that checks out. All right, so the red is the check. Let's go over yonder. I'll use yellow in this case. So now we're going to be using the different point. I'm even going to use a different method. I'm going to use the y equals mx plus b method. So there's our slope, and notice what's missing is the b. So to find the b, we plug in our xy point and solve for b. So add 6 to both sides. After we add 6 to both sides, we get b equals 2. And so you would want to complete that. We knew m was -2, but now we know that b is 2. And we get the same answer as before. So it doesn't matter what point we use. Okay. And again, if we wanted to check our work at this point, you could plug in, let's see, here we use 3, -4 to get this equation. That means I would use the other point just to make sure everything looks good. And it does. -2 times -2 is +4, and +4 plus 2 is 6. So we knew that works out. So that checks out. We're good to go. All right, and again on the exam, you guys only have to do one of these methods. There's actually 4 ways to do it. Just do one, show me you get the right answer, and you're good to go. All right, let's look at a variation. We are going to find the equation of the line that contains a point and is parallel to y equals 4x minus 6. Okay, so normally we know that we need a point and a slope. In this case, we have a point and a line. But we know the line is, our new line is going to be parallel to this line. Well, what do we know about parallel lines? They have the same slope. So our line is going to contain the point 1, 4. It's going to be parallel to y equals 4x minus 6. So that actually means the slope of our new line has to be the same, because parallel lines have the same slope. All right, so now using this information, we're back in case 2. All right, so why don't you pause it, see if you can come up with the solution, and then come on back and watch the solution. I'm using point slope form. Y minus y1 equals m times x minus x1. Solve for y, so that means we're going to distribute the 4 to the x minus 1. And then let's add 4 to both sides. Ooh, and it actually cancels on both parts. So it's y equals 4x. All right, and we would check. We could put the point 1 comma 4 into y equals 4x. So y equals 4, x equals 1, and that checks out. And then notice we also have that slope of 4, so we're good to go. Okay. So let's take that same problem, and let's say that now it's perpendicular to that same line. So what do we know about the slope of perpendicular lines? They're negative reciprocals. So in other words, whatever the slope is, we're going to flip it and change the sign. Okay, so now we have a line going through the point 1, 4, but now our slope is negative 1/4. So let's see how that changes. So y minus y1 is equal to m times x minus 1. Oops. Solve for y, so distribute that negative 1/4. Negative times negative is a positive 1/4. All right, and then solving for y, let's add that 4. All right, and this is a nice review. When we add fractions, we need the same denominator. So rather than writing 4, we would have to match this denominator that we're trying to add. So we can think of 4 as 4 over 1. 1 times what is 4? 1 times 4 is 4. So to make sure everything stays balanced, whatever we do the bottom, we do the top. And so instead of adding 4, we're going to think of it as 16/4. And we know 16 divided by 4 is actually 4, so that makes sense. Okay, so let's just do a little side work. So 16 over 4, that's your 4 plus a fourth. When we add fractions, denominators stay the same, and we add the top. 16 plus 1 is 17 over 4. Whew. Okay, so our answer, I will write it in black to stand out, is y equals, that goes to 0, negative 1/4 x plus 17 over 4. Okay, so there you go. We have some equations for you guys to do on your own in example 4. We have a point, 3, 4, just as before in that previous example. And we're going to do a line that's parallel to this line and one that is perpendicular to that line. All right, so let's see how you guys did. So we have a point and we know it's parallel to a line. So your first step is to solve this for y, because once it's in y, we know the slope of that line, which is 3/4, and we want a line that's parallel to this line with a slope of 3/4. That means our new slope is 3/4. All right, so if it's parallel to this line, it means they have the same slope. To figure out the slope, you need it in y equals mx plus b form. So now that we have a slope and a point, I use point slope form. There's 3, 4 with our slope. I solved it. Remember, when we're adding fractions, 4 is like 16 over 4, and this is our line. All right, and then finally, let's look at this. Let's see if you guys got this correct. We want a line that's perpendicular to y equals 6. All right, I'm going to draw a quick sketch of this. Sometimes visually it's a little bit nicer to see. Y equals 6. There's only one variable, y. There's no x. That means it's either horizontal or vertical. Well, if y equals 6, there's y equals 6. Whoops, I just missed it. It's a horizontal line because y is always 6. We don't go up or down. And now we want this through the point 3, 4. So we'll just guesstimate. Maybe it's right here. 3, 4. And we want a line that's perpendicular. Well, what kind of line is perpendicular to a horizontal line? A vertical line. So what's the x value of this vertical line? 3. It's going through 3. So the answer here is x equals 3.